One of my favorite topics in geometry, and really I think where a lot of what we'll talk about really stems from and is really built from, is the topic of triangles. Triangles obviously are shapes that have three angles, right? Triangles. But a little bit more about triangles, they also have three sides and they're also closed. And you can see an example of a triangle here. You could have three-sided objects that aren't closed, right? Something like this. That's not closed. That's not a triangle just because it has three sides. You have to have three angles too. So anyway, we need it closed. We need three angles, three sides. And there's a really important property of triangles. This is true for every triangle, not just the one I have drawn up here. If you consider the two lines up here as being parallel, this line and this one as being two parallel lines, then we already know some interesting theorems about the angles with parallel lines and transversals. And so now if you consider that there's two transversals technically creating this triangle, and we know that angles 1 and 2 are alternate interior angles. So angle 1 is congruent to angle 2, meaning they have the same measure. Same with angles 3 and 4 on this diagram. Okay, so angle 3 is congruent to angle 4. All right. Now, if you look up at the top here, you can see that there are three angles that make up a straight angle, which means that if you add angles 2, 5, and 4 together, you'll get 180 degrees, okay, because it's a straight angle. So measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 must be 180 degrees, okay? So again, the first two congruencies here are because of alternate interior angles, and this last one is because you have a straight angle up there, okay, made up of three different angles. And so if you think about this relationship, if angle 1 and angle 2 are congruent, that means the measure of angle 1 and the measure of angle 2 are the same. So really you could take measure of angle 2 and replace it with the measure of angle 1. Same for 4 and 3, right? If those two angles are congruent, then their measures are interchangeable. They're the same. So the measure of angle 4 must equal the measure of angle 3. And so what's really interesting about this new equation is that the three different angles that are listed are the three different angles on the inside of the triangle. Again, this is true no matter what the size of the triangle is. Notice I didn't actually put any particular values there. This could be any size triangle or any shaped triangle. And so what we end up with is a theorem that says the sum of the three interior angles of a triangle is always equal to 180. And that's always true no matter what the size or layout of that triangle is. So this is a theorem. The sum of the interior angles of a triangle is always 180 degrees, okay? That is always, always true. All right, we're going to use that fact to do a lot of different things. The first thing we're going to do is solve this problem up here that I have in red, where we have multiple unknown angles, but three given angles. And the three given angles are strategically placed so that we can find the rest. The first one, we have a 90-degree angle, a right angle up here, and that is alongside angle 1. Now angle 1 and the right angle are obviously on a straight line, which makes them add up to 180. So if I go through this, let's see, look over here. The measure of angle 1 plus that 90-degree angle must be 180, which of course by subtracting the 90 leads us to the fact that the measure of angle 1 is itself 90 degrees. Okay, so that gives us one answer, 90 degrees for angle 1. Then we look at angle 2. And angle 2 can be determined because I already know angle 1 and the 38 degrees down here, and I know this theorem, that the sum of the three angles, now it doesn't have to be 135, that just happens to be the labeling that I used in the first example, but what is important is that the three angles on the inside add up to 180. So we take the measure of angle 1 plus the measure of angle 2 plus 38 degrees equals 180. Measure of angle 1 I know to be 90 degrees, so I'm going to throw a 90 in there. Now if I add 90 and 38, that gives me 128. So the measure of angle 2 plus 128 is equal to 180. And all I have to do is subtract off the 128. And what's 80 minus 120? 52, right? So measure of angle 2, in fact, I'm going to put this off to the side. Measure of angle 2 is equal to 52 degrees. So that does give me a second angle now. Okay. Now, if I go to angle 3, well, angle 3 is a vertical angle to angle 2, which means that they're congruent, right? Vertical angles are congruent, which means the measure of angle 3 is also equal to 52 degrees. So plot that in there, it's because they're vertical and congruent. And then again, if this is 52 and I have a 55 degree angle up top, I can find angle 4 by using my angle sum formula again. Okay, so bring it over here this time. Measure of angle 3 plus the measure of angle 4 plus that 55 degree angle is going to be 180. I already know that angle 3 is 52 degrees. And if I add the 52 and the 55, that's 107 degrees. So the measure of angle 4 plus 107 degrees is equal to 180 degrees. I do the subtraction to get measure of angle 4. And what's that going to be? 73 degrees, right? So the measure of angle 4 equals 73 degrees. And then of course angle 5 over here on the end is supplementary to angle 4 because the two of them make up a straight line again, a straight angle. And so I know that the measure of angle 4 plus the measure of angle 5 must be 180. Measure of angle 4, I know to be 73. Lost track of it there for a second. 73 degrees. So I'm going to subtract the 73 degrees from both sides of this equation. And I'm going to get 103 degrees. So measure of angle 5 is going to be 103 degrees. So fun little example where you get to play with that property quite a few times there, along with a couple other important things like straight angles and vertical angles. One thing that's really interesting, I might point out, is that because of this theorem, the exterior angle of a triangle is also equal or congruent, I should say equal, measure is equal to the sum of the opposite interior angles, or the other interior angles. If I point that out, notice that in this, the exterior angle here, 5, happens to be the sum of the 55 and the 52, right? Which is kind of interesting. That's also always going to be the case for the exterior angle of a triangle, if you imagine drawing one of the sides through or continuing one of them on, will always add up to the, or will always be the sum of the opposite interior angles, the interior angles that are opposite that exterior angle. So, because of course the 3 on the inside add up to 180, and these two here, 4 and 5, have to add up to 180. If they add up to the same thing, you pull the 4 out, then 5 has to be the other 2. Okay, so that'll always work out as well. It's something kind of interesting to point out.